अस्सलाम वालेकुम। चैप्टर 6 में खुश आमदीद। आज के इस एक्सप्लेनर में हम स्टोरेज डिवाइसेस की दुनिया में डाइव इन करेंगे। जरा सोचें, हमारा सारा डिजिटल डेटा, गेम्स और वीडियोस आखिर कहाँ और कैसे महफूज होते हैं। आज हम मैग्नेटिक और ऑप्टिकल स्टोरेज के इन कॉन्सेप्ट्स को बिल्कुल क्लियर करेंगे, और वो भी बहुत ही सिंपल और मज़ेदार मिसालों के साथ। तो क्या आप तैयार हैं?
तो आज का एजेंडा क्या है? हम इन 5 मेन पॉइंट्स को देखेंगे। स्टोरेज डिवाइस की बेसिक डेफिनेशन से लेकर मैग्नेटिक और ऑप्टिकल टेक्नोलॉजीज को समझेंगे, इनका कंपैरिजन करेंगे और फिर देखेंगे कि आपकी ज़रूरत के हिसाब से राइट चॉइस कौन सी है। लेट्स गो।
क्विकली जंप करते हैं सेक्शन 1 पर। स्टोरेज डिवाइस क्या है?
इसे समझने के लिए सोचें कि ये आपकी एक डिजिटल तिजोरी या सेफ है। जिस तरह हम तिजोरी में अपने कीमती डॉक्यूमेंट्स और चीज़ें लॉक करके रखते हैं, बिल्कुल वैसे ही ये डिवाइसेस आपका ऑपरेटिंग सिस्टम, अहम डॉक्यूमेंट्स, यादगार तस्वीरें और वीडियोस को फ्यूचर के लिए संभाल कर रखती हैं। अगर ये डिजिटल तिजोरी ना हो तो यकीन करें, कंप्यूटर ऑफ करते ही सब कुछ गायब हो जाएगा।
अब इस डिजिटल तिजोरी की 2 मेन टेक्नोलॉजीज या कह लें कि टूल किट्स हैं, जिन्हें आज हम अनलॉक करेंगे। पहली है मैग्नेटिक स्टोरेज डिवाइसेस और दूसरी हैं ऑप्टिकल स्टोरेज डिवाइसेस। चलें देखते हैं कि ये अंदर से कैसे काम करती हैं।
आगे बढ़ते हैं सेक्शन 2 की तरफ। मैग्नेटिक स्टोरेज डिवाइसेस। कभी सोचा है कि एक मैग्नेटिस आपकी डिजिटल फाइल्स को कैसे सेव कर सकता है?
देखिए, नाम से ही जाहिर है, मैग्नेटिक स्टोरेज डिवाइसेस मैग्नेटिक मटेरियल का इस्तेमाल करती हैं। ये कोई कागज़ कलम वाला सीन नहीं है, बल्कि यहाँ डेटा फिजिकल तौर पर मैग्नेटिक पैटर्न्स की शक्ल में राइट होता है। ये पैटर्न्स ही हमारे कंप्यूटर की ज़ीरोज़ और वंस, यानी 0s और 1s वाली ज़बान बनते हैं। अच्छा, अगर हार्ड डिस्क ड्राइव यानी HDD की बात करें और इसे अंदर से देखें ना, तो ये बिल्कुल पुराने ज़माने के रिकॉर्ड प्लेयर जैसी दिखती है। इसमें गोल्ड डिस्क्स होती हैं जो बहुत तेज़ी से स्पिन करती हैं, और एक छोटा सा रीड राइट हेड उन घूमती हुई डिस्क्स पर डेटा लिखता और पढ़ता है। हमारी हैवी फाइल्स और ऑपरेटिंग सिस्टम्स का असल घर यही है।
लेकिन हर चीज़ परफेक्ट तो नहीं होती, राइट? HDD का कमाल ये है कि इसमें गुंजाइश बहुत ज़्यादा है और ये सस्ती भी बहुत पड़ती है। लेकिन इसका नुकसान, चूंकि इसमें मूविंग पार्ट्स हैं, नाजुक पुर्जे हैं, इसलिए अगर ड्राइव खुदा ना खास्ता गिर जाए तो समझें डेटा गया। फिजिकल शॉक का खतरा रहता है। और हाँ, ये लेटेस्ट टेक्नोलॉजीज़ के मुकाबले में थोड़ी स्लो भी होती है।
मैग्नेटिक स्टोरेज की एक और पुरानी लेकिन बड़ी कमाल की किस्म है मैग्नेटिक टेप। अब ये रोज़मर्रा के इस्तेमाल की चीज़ नहीं रही। इसे आप पुरानी ऑडियो कैसेट्स की तरह की एक लंबी मुसलसल पट्टी समझ लें। आजकल इसका असल काम बड़े बड़े आर्काइव्स या कंपनियों का हिस्टोरिकल बैकअप लंबे अरसे के लिए रखना है। इसका सबसे बड़ा प्लस पॉइंट ये है कि लॉन्ग टर्म बैकअप के लिए ये लिटरली बहुत सस्ती है। मगर इसमें एक बड़ा मसला है, वो है सिक्वेंशियल एक्सेस या तरतीबवार रसाई। मतलब अगर आपकी मतलूबा फाइल टेप के बिल्कुल आखिर में है, तो आपको पूरी टेप रिवाइंड या फॉरवर्ड करनी पड़ेगी वहां तक पहुंचने के लिए। बिल्कुल पुरानी कैसेट्स की तरह अगला गाना लगाने वाला सीन। काफी स्लो प्रोसेस है ना? चले, अब मैग्नेट से निकलकर रोशनी और लेजर्स की दुनिया की तरफ चलते हैं। सेक्शन 3, ऑप्टिकल स्टोरेज डिवाइसेस। तो ऑप्टिकल स्टोरेज क्या है? यहाँ मैग्नेट्स का कोई चक्कर नहीं, यहाँ सारा गेम लेजर बीम्स का है। ये डिवाइसेस चपटी, गोल और चमकदार डिस्क्स पर डेटा रीड और राइट करने के लिए रोशनी की शुआ यानी लेज़र टेक्नोलॉजी यूज़ करती हैं। ये मैग्नेटिक ड्राइव से बिल्कुल डिफरेंट टेक्नोलॉजी है।
इन डिस्क को समझने के लिए एक सिंपल सी बॉक्स वाली मिसाल लेते हैं। सोचें कि CD एक छोटा सा डब्बा है जिसमें कम सामान आ सकता है। DVD एक दरमियाने साइज का डब्बा है जिसकी कैपेसिटी ज़्यादा है। और ब्लू-रे वो एक बहुत ही बड़ा डब्बा है जो सबसे ज़्यादा डेटा अपने अंदर समो सकता है। ये मिसाल इनकी स्टोरेज लिमिट्स को बिल्कुल क्लियर कर देती है।
अब हर डब्बे का अपना एक ख़ास इस्तेमाल है। CD बेसिक डेटा या म्यूज़िक के लिए ज़बरदस्त है। DVD मूवीज़ या बड़े सॉफ्टवेयर्स के लिए। लेकिन ब्लू-रे बिल्कुल नेक्स्ट लेवल है। ये एक ख़ास ब्लू वायलेट लेज़र यूज़ करती है, जिसका मतलब है ये बहुत ज़्यादा डेंसिटी के साथ डेटा महफूज करती है। HD वीडियोज़ और बहुत हैवी फाइल्स के लिए ये परफेक्ट है। ऑफ कोर्स, इन चमकदार डिस्क्स को हम हवा में तो नहीं चला सकते। इनको रीड या राइट करने के लिए जो हार्डवेयर चाहिए होता है, उसे ऑप्टिकल डिस्क ड्राइव या ODD कहते हैं। ये आपके कंप्यूटर के अंदर भी लगी हो सकती है और अलग से एक्सटर्नल डिवाइस के तौर पर भी मिल जाती है।
अच्छा, इनके फ़वाइद क्या हैं? ये बहुत पोर्टेबल है, जेब में डीवीडी डाली और जहां मर्जी ले गए। मीडिया प्लेबैक के लिए ज़बरदस्त हैं, मगर नुकसानात, इनकी स्पीड थोड़ी स्लो होती है और सबसे डरावनी चीज़, अगर डिस्क पर एक गहरा स्क्रैच आ गया ना, तो समझे आपका सारा कीमती डेटा हमेशा के लिए ज़ाया।
सेक्शन 4 मैग्नेटिक बामुकाबला ऑप्टिकल। अब इन दोनों को आमने सामने रखकर देखते हैं। आइए एक क्विक कंपैरिजन करते हैं ताकि सब क्लियर हो जाए। मैग्नेटिक में हमारे पास एचडीडी और टेप हैं जो मैग्नेट्स यूज़ करती हैं। गुंजाइश बहुत ज़्यादा होती है और ये रैंडम या सीक्वेंशियल रसाई देती हैं। दूसरी तरफ ऑप्टिकल में सीडी, डीवीडी और ब्लू-रे हैं जो लेज़र पे चलती हैं, मीडिया प्लेबैक के लिए बेस्ट हैं और पूरी तरह इन नाजुक डिस्क्स पर बेस करती हैं। ये फ़र्क टेक्नोलॉजी को समझने के लिए वाकई बहुत अहम है।
अब आते हैं अपने आखिरी और सबसे प्रैक्टिकल हिस्से की तरफ, सेक्शन 5 सही स्टोरेज का इंतखाब।
तो फैसला कैसे किया जाए? बहुत सिंपल है। अगर रोज़मर्रा के इस्तेमाल के लिए कंप्यूटर की बड़ी बड़ी फाइल स्टोर करनी है तो ब्लाइंडली एचडीडी की तरफ जाएं। अगर किसी कंपनी का पुराना डेटा बरसों के लिए महफूज करना है तो मैग्नेटिक टेप इज़ द बेस्ट। और अगर आपको फिल्में देखनी है, दोस्तों को कोई सॉफ्टवेयर देना है या मीडिया प्लेबैक चाहिए तो फिर सीडी, डीवीडी या ब्लू-रे चूज़ करें। हर डिवाइस का अपना एक खास काम है।
लेकिन इस सब के बाद एक सवाल जहन में ज़रूर आता है। हमने देखा कि HDDs के मूविंग पार्ट्स टूट सकते हैं और ऑप्टिकल डिस्क स्क्रैचेस की वजह से ख़राब हो सकती हैं। तो फिर इंतहाई महफूज डेटा स्टोरेज का मुस्तकबिल क्या है? क्या हमें ऐसी टेक्नोलॉजीज़ की ज़रूरत नहीं जिनमें कोई हरकत करने वाला पुर्जा ही ना हो? खैर, ये वाकई सोचने की बात है और नए दौर की सॉलिड स्टेट ड्राइव्स की तरफ इशारा करती है। इसी थॉट के साथ हम आज के इस एक्सप्लेनर को यहीं वाइंड अप करते हैं। अपना बहुत ख्याल रखिएगा। अल्लाह हाफिज़।
Active digital data is entirely volatile. The moment power is lost, everything vanishes. To survive, information requires physical permanence. A storage device provides that permanence. It is the physical hardware that safely holds operating systems, application software, and document files. Modern physical storage architecture is strictly divided into two primary categories: magnetic storage and optical storage. These two systems rely on entirely different laws of physics to encode and retrieve digital information. Knowing whether a device manipulates magnetic fields or focuses light reveals exactly what it is capable of regarding capacity, read speed, and practical application. Magnetic storage uses localized magnetic fields to alter the polarity of a physical material, creating persistent data patterns. Optical storage uses concentrated laser technology to read microscopic physical variations on a flat rotating surface. While the mechanisms are entirely distinct, both serve the exact same purpose. They translate those physical states back into readable digital files. To understand why both technologies remain in active use, we have to analyze their physical geometry. The physical shape of the storage medium directly limits how quickly a computer can locate and read the information stored on it. The hard disk drive is the most common manifestation of magnetic storage architecture. Inside an HDD, a stack of circular platters spins rapidly, while a mechanical arm sweeps across the surface, reading and writing magnetic polarities. The foundational engineering required for this technology initially demanded massive vertical assemblies of magnetic disks. This spinning, circular design allows for high-speed random access. The read head can jump immediately to any file, making it highly effective for running active applications. The density of magnetic recording also grants the HDD a massive storage capacity advantage. But that capacity comes with an inherent vulnerability. The reliance on moving mechanical parts means an HDD is susceptible to physical shock and damage. Those same mechanical constraints place a hard limit on its read and write speeds, leaving it considerably slower than modern solid-state memory. The hard disk drive is an exercise in practical engineering. It trades mechanical durability for massive, cost-effective computing capacity. A completely different geometric approach to the same magnetic principles is found in the long, linear strip of magnetic tape. By stretching the magnetic material into a continuous ribbon, the method of locating files completely changes. Tape relies on sequential access. This diagram shows how, to retrieve a file stored at the end of the roll, the machine must physically spool past all the preceding blocks of data. Early computing mainframes relied heavily on these large reel-to-reel magnetic tape systems to process sequential datasets. Because of the immense time penalty required to spool through data sequentially, tape is entirely useless for active computer operations, where files are needed instantly. Yet the format survives because the physical material is extremely cheap to manufacture, allowing massive data centers to house vast libraries of information. The linear geometry of magnetic tape sacrifices fast retrieval to achieve the most cost-effective solution for deep archival backup. Leaving magnetic fields behind, we can evaluate a technology driven by the physics of light: optical storage. This category uses a highly concentrated laser beam to interpret microscopic variations along the surface of a flat, circular disk. To access these disks, a computer requires an optical disc drive, or ODD, which houses the precise laser assembly either internally or as an external peripheral. The baseline format is the compact disc. Initially engineered for portable music, its stability quickly made it a standard for software distribution. The primary limitation of the CD is its low data density, offering a relatively small storage capacity by modern standards. The engineering response was the digital versatile disc, or DVD. It maintains the exact same physical dimensions as the CD, but packs data much closer together, significantly increasing density. With this expanded capacity, DVDs became the dominant medium for full-length movie playback and housing massive software installations on a single disc. By keeping the physical disc size uniform and refining the laser reading technology, early optical media streamlined how large software packages and entertainment were distributed. The taxonomy of optical storage reaches its highest iteration with the Blu-ray Disc. Instead of the standard red lasers used in CDs and DVDs, a Blu-ray drive utilizes a specialized blue-violet laser. This diagram shows the core physical advantage. A blue-violet laser has a much shorter wavelength than a red laser, allowing it to focus on smaller, tightly packed data pits. Because the laser is more precise, information density on a standard disk skyrockets. This extreme capacity is required for storing entirely uncompressed high-definition video playback and executing large-scale archival data backups. However, all optical formats share structural weaknesses. Their read speeds are slow compared to modern solid-state memory, and a single deep scratch on the disk's surface can cause catastrophic data loss. The Blu-ray disc maximizes the physical limits of optical storage. By manipulating the wavelength of the light used to read it, engineers extracted maximum capacity from a static physical surface. Architects evaluate hardware on storage capacity versus access speed. Magnetic storage occupies extremes. Hard drives offer high capacity and moderate speed, while tape delivers maximum capacity at minimal speed. Optical formats scale from CD to Blu-ray, prioritizing physical portability over raw speed. Magnetic hardware is built for heavy, localized data ecosystems. Optical media is designed to be written once, transported, and played back anywhere. There is no universally superior storage device. The hardware must be strictly matched to the systemic requirements of the user. Selecting the right architecture requires balancing speed, capacity, and the financial cost of your use case. To run complex operating systems and access large, active local files, the random access speed of a hard disk drive is necessary. For securing immense enterprise-level data archives over decades, the sequential mechanics of magnetic tape remain the most cost-effective choice. And to physically distribute uncompressed high-definition media, the microscopic laser density of a Blu-ray disc is essential. By understanding the underlying physics of persistence, from shifting magnetic domains to precise laser topography, we can engineer highly efficient, purpose-built digital ecosystems.
Assalamu alaikum, welcome to today's explainer. आज हम समझेंगे the nuts and bolts of data storage. I'm your host, and today we're breaking down Chapter 06 of Yashab Sarfraz's really excellent course on applied sciences and computer safety. Specifically, we are going to dive deep into the fascinating world of magnetic and optical storage devices and find out exactly how they actually work behind the scenes.
So let's kick things off with the absolute basics. What actually is a storage device? Well, think of it like a massive digital filing cabinet for your computer. It's the physical hardware where everything lives, your operating system, all your apps, and every single document, photo, and video you've ever saved. These devices are absolutely crucial because they keep your data safe and ready for future use. I mean, without them, your computer would literally just forget everything the second you unplugged it.
Here is a quick look at our roadmap for this explainer. We're going to start with magnetic storage, then move over to optical storage, look at some real-world use cases, and then wrap it all up with a quick revision. Let's jump right in.
All right, part 1, the heavy lifters. These are our magnetic storage devices, which use magnetic patterns to hold on to your data. To make sense of all this, it really helps to split storage tech into two main camps. On the left side, you've got magnetic storage. This includes things like hard disk drives and magnetic tape. They're built from magnetic materials, and they are famous for giving you massive storage capacities. On the right side, we've got optical storage, your CDs, DVDs, and Blu-ray discs. Now, instead of magnets, these use ultra-precise laser technology, and they absolutely shine when it comes to media playback and archiving. Today, we're unpacking exactly how both of these totally different technologies manage to handle your data.
Let's zoom in on a super common magnetic device, the hard disk drive, or HDD. If you were to crack open a standard HDD, you wouldn't just find a boring, solid block of metal. Inside, there are these incredibly fast-spinning disks called platters, and a tiny mechanical arm that zips back and forth across them. That arm is the read and write head. It uses magnetic fields to physically write data onto those spinning platters and read it back at just unbelievable speeds.
Now, where do we actually use these things in real life? HDDs are essentially the workhorses of standard desktop computers. They are perfect for holding massive amounts of everyday stuff. We're talking your whole operating system, heavy software, and huge video libraries. The big win here is you get a ton of space for a really low cost. But it's definitely not perfect. Because it relies on those spinning disks, it's kind of like a tiny record player inside your computer. If you drop it, those fragile moving parts can easily break. And all that mechanical movement does mean it's noticeably slower than a modern solid-state drive. Before we look at our next magnetic device, we need to understand something called sequential storage. This just means data is saved and accessed in a strict, linear order. Think of it like trying to fast-forward an old audio cassette tape. If you just want to hear the very last song, you can't magically skip straight to it. You have to physically wind past every single other song first just to find what you're looking for.
And that is exactly the deal with magnetic tape. Design-wise, it's literally just a long strip of plastic coated in magnetic material. Now, obviously, you're not going to use magnetic tape to save a quick Word document or boot up a video game. But say you're a global bank and you need to securely archive 30 years of financial records without going bankrupt, tape is absolutely your best friend. It is incredibly cheap for storing staggering amounts of data over decades. The catch, of course, is that sequential access. Searching through years of tape just to find one specific file takes a very long time. So it's built for preserving history. Definitely not for speed.
Okay, moving right along to part 2 of the explainer, the media masters. Unlike magnets, these optical storage devices use lasers to read and write data.
Optical storage devices are those classic flat, shiny disks that go into an optical disc drive. We are going to trace how this media evolved across 3 major generations, starting with the compact disc, then stepping up to the digital versatile disc, and finally landing on the Blu-ray disc. With every single step, the technology got tighter and more refined, giving us way more data capacity.
Let's look at step 1, the compact disc, or CD. If you were around for the music boom in the 90s, you know CDs. They completely revolutionized the audio industry by using lasers to read digital sound. A bit later, they became the default way to share computer software and basic files. They're super portable and foolproof to use. However, their biggest limitation today is space. They hold the absolute lowest capacity compared to the disks that eventually replaced them.
Because we desperately needed more digital space, we naturally progressed to the DVD, which stands for Digital Versatile Disc. Now, to the naked eye, a DVD looks exactly like a CD, but the technology packed inside allows for a massively higher storage capacity. Because of all that extra room, DVDs became the undisputed global standard for heavier files. They were the absolute go-to for full-length standard definition movies, big software suites, and backing up your computer. But tech never stops, right? Files kept getting bigger, especially when high-definition video exploded onto the scene. That is where Blu-ray stepped in. Instead of the standard laser used for DVDs, a Blu-ray uses a highly specialized blue-violet laser. This laser is much finer, which means data can be packed together at a vastly higher density on a disc that is exactly the same physical size. Thanks to that blue-violet laser, Blu-ray holds the absolute highest capacity of any optical disc on the market. It is the ultimate real-world solution for pristine 4K movies and massive datasets. But there is a catch you have to remember with all optical media. First, the drives themselves are pretty slow compared to a modern hard drive. And crucially, because all your data lives right there on an exposed physical surface, one bad scratch can totally ruin your files. You really have to handle them with care.
All right, section 3, and honestly the most practical part of this whole explainer, real-world use cases. Let's figure out how to match the right storage device directly to your daily needs. It really all comes down to picking the right tool for the job. Need to store heavy, everyday computer files and run an operating system? You want a hard disk drive. Are you running a massive corporation that needs to archive decades of data where speed doesn't matter, but long-term survival does? Go with magnetic tape. And if your goal is distributing blockbuster movies, selling physical software, or just enjoying high-def media at home, then optical devices like DVDs or Blu-ray discs are exactly what you need. We've covered a ton of great ground today, so let's hit section 4 for a quick revision to lock all of this in.
Here is your cheat sheet. On the magnetic side, hard disk drives are your go-to for large-capacity daily storage, while magnetic tape is the undisputed, low-cost champion for long-term archival backups. On the optical side, CDs are for music and basic data, DVDs stepped up the game for standard movies and software, and Blu-ray discs are the heavy hitters you need for high-definition video and massive files.
To wrap things up, I want to leave you with a thought. As our digital footprint absolutely explodes every single day, do you think physical storage devices will eventually be completely wiped out by the cloud? It's pretty fascinating to think about where this is all heading. Anyway, we've thoroughly detailed the types of storage devices today based on Yashab Sarfarz's course. If you found this explainer helpful, please hit that like button, subscribe, and share it around. Oh, and definitely drop your city name in the comments below. It really helps boost our motivation. Thanks so much for hanging out with us, and Allah Hafiz.
Welcome, everyone. Today we're diving into the mechanics of memory. We're doing a full explainer on Yashab Sarfarz's Chapter 06 quiz covering magnetic and optical storage. We're going to bypass that basic quiz format and dig straight into the actual core concepts of how our devices hold on to our data. Okay, let's dive into this. To kick things off, we really have to ask the most fundamental question. What is the main function of a storage device? It sounds super basic, right? Well, the answer, saving digital data, is literally the anchor for everything we're discussing today. Every single piece of hardware we're going to look at exists just to perfect this one singular goal.
So here's our roadmap. We're covering 6 key areas today: storage categories, magnetic storage, magnetic tape, optical technology, optical evolution, and a final evaluation. Nice and simple.
All right, Section 1, Storage Categories. Chapter 06 splits the entire world of storage straight down the middle into 2 distinct families. You got magnetic storage on one side, which relies purely on magnetic material to save your data. And then, on the flip side, optical storage completely abandons magnets, relying instead on precision laser technology. Basically, any storage problem you run into is going to be solved by going down one of these 2 fundamental paths. Let's move to and see how this builds in Section 2, Inside Magnetic Storage. First up, the hard disk drive, or HDD. This thing is the absolute physical workhorse of the computing world. By using physical spinning disks, it manages the heaviest, most critical data you own. You know, this isn't just for tossing a few files around. This is the literal home base for your entire operating system and your heaviest daily applications. So the crucial point is the major advantage of the hard disk drive, which is its massive storage capacity. When you absolutely need to hold an enormous amount of data, we're talking thousands of high-res photos or massive programs. The HDD is the undisputed heavy lifter. It's the whole reason you can store entire operating systems all in one place without immediately running out of room. But, you know, we've got to balance that massive advantage with physical reality. The HDD has a pretty critical limitation. It relies on physical, moving parts. Because those disks inside are constantly spinning at incredibly high speeds, they are super vulnerable to mechanical wear and tear, or heaven forbid, a drop. So it's a clear trade-off. You get this incredible capacity, but you absolutely have to treat the hardware with mechanical respect. Section 3, Archival Power, Magnetic Tape. Now, magnetic tape is a whole different beast. It remains the ultimate data backup and archival solution. Seriously, major organizations, massive businesses, huge server farms, they aren't using this for fast everyday access. They use magnetic tape to safely lock away massive amounts of data for a rainy day. It's basically a giant digital vault. But why wouldn't you use it for quick access? Well, magnetic tape operates on sequential order. You literally have to start at the beginning of the physical tape and read the data strictly in sequence. You can't just skip ahead. Only after going through everything before it do you finally arrive at your requested file. This sequential access costs a lot of time, making it pretty much impossible to instantly jump to a file like you do on a standard hard disk drive.
Okay, time to pivot away from magnets entirely. Section 4, Optical Technology. Here is the actual hardware that makes this entirely different storage family possible. The OD, or Optical Disc Drive. This completely leaves behind those spinning, magnetic materials and instead uses highly focused lasers to read and write data onto CDs, DVDs, and Blu-ray discs. With optical, it's all about reading tiny, microscopic reflections of light. Now, what's really interesting here is the unique vulnerability of optical media. Because the drive uses precision lasers to read the surface, these discs are highly vulnerable to physical scratches. A simple scratch on the plastic can deflect the laser, completely defeating all that advanced technology and causing major data reading problems. It's a brilliant reading system for sure, but it absolutely requires the disc surface to remain pristine. Section 5, Evolution of Optical Discs. Let's take a look at where this started. The CD, or compact disc. This was the true pioneer of everyday optical storage, and it initially became famous for storing digital music. It totally revolutionized the industry by allowing everyone to shift from those old magnetic cassettes to a crisp, pristine, laser-read digital format. Then came the next massive evolutionary step, the DVD, or digital versatile disc. The key word here is versatile, which came right alongside a huge jump in storage capacity compared to the CD. Because it could hold so much more data, it wasn't just for music anymore. It quickly became the essential tool for storing full-length movies, handling heavy software installations, and performing significant data backups. And looking at this progression brilliantly illustrates the entire optical journey side by side. We step up from the CD for music, straight up to the DVD for movies and software, and finally, we reach Blu-ray, which is best for high-definition movies and massive files. Its real technological edge, a tightly focused blue-violet laser. That tiny change in the laser's wavelength allows it to pack in significantly more data than a standard DVD ever could.
Section 6, Final Evaluation.
All right, I'm going to challenge you directly with the final question from Yashub's quiz. To store a high-definition movie and large data files, which specific option is best? Think about the journey we just took. A CD, way too small. Magnetic tape, too slow because of that sequential access. A standard DVD, probably not going to hold a modern high-def file. So the ultimate answer, confirming its place right at the top of the optical evolution, is the Blu-ray disc.
Yashub Sarfaraz leaves us with a really great closing rubric to test your knowledge. If you got 20 or more correct on his quiz, excellent work. If you scored 15 to 19, use this explainer to go back and revise that core comparison between magnetic and optical storage. And hey, if you scored less than 15, no worries. Just rewatch this and make sure you memorize the specific use cases for HDD, tape, CD, DVD, and Blu-ray. Before we wrap up, I want to leave you with a provocative thought. We've seen how we moved from basic magnetic spinning disks all the way to advanced blue-violet lasers, just to keep up with our constant need to store larger and larger files. So, as high-definition files continue to grow massive, what revolutionary technology is eventually going to replace magnets and lasers altogether? It's a fascinating question for the future of computer science. Thanks so much for joining me on this explainer, and I will see you next time.